Okay, we have a converse statement. A converse statement is a statement gotten from a conditional statement by interchanging the antecedent and the consequent. So if you interchange the antecedent or the hypothesis with the consequent or the conclusion, we have a converse statement. As you can see, P implies Q is a conditional statement. Then if you interchange the two, P and Q, we have a converse statement. So the next one, there is what we call biconditional statement. So a biconditional statement is a statement that uses if and only if. So if you see this if and only if, or maybe if you see this symbol, you know there is a biconditional statement. It is a statement that both the first and the second statement determines the results. Okay, look at this. They said A, goats are intelligent. B, vertebrate animals are intelligent. Now, so what is the symbolic representation of vertebrate animals are intelligent if and only if goats are not intelligent? So first, vertebrate animal are intelligent is B. So we'll write it. If and only if, that's the symbol. If and only if goats are not intelligent. So goats are intelligent is A. So not intelligent is now negate A. So that's it. That's the symbolic representation. So let's move to what we call truth table. So a truth table is a table that shows how truth or falsity of a compound statement. It depends on the truth or the falsity of the simple statements from which it is constructed. So if you have two simple statements combined with connective, we have a compound statement. So from there, we now know how true a table that we use in showing how true or false the statements are. So look at this. They say generally, this is now like a general formula before we now use tables and do the truth tables. Generally, if P and Q are two simple statements, then P, remember this means or P or Q is false when both P and Q are false. So it's always false if both of them are false. That's the only condition for it to be false. Otherwise, it's always true. Second one, P and Q is true when both of them are true. So before the P and Q be true, both P and Q must be true. Why the third one, P implies Q, is false. So P implies Q is false when P is true. That's when the hypothesis or the antecedent is what? True. Why the consequence or the conclusion is false. So that's the only time conditional statement is false. So when the first one is true, why the second one is false? That's the only time is false. So coming to this bicondition, I told you bicondition from what you said, both of them must be true or both of them must be false for it to be true. So they must be true. In conditional is only the consequence determines how true it is, but in this case, in biconditional, both of them must be involved. So either true or false. That gives us true. So look at this question. Let me use it and prove. Okay, they said if A and B are logical statements, prove that A implies B is equal to not B implies not A. So look at this table. We are going to use it to fill up this so that we know that whether is correct. For it to be correct, the second to the last column must be the same as the last column. So whatever that is here must be there. Whatever that is here, so the two must be equal. So let's start with A, B. So A, condition for A and B. When A is true, so when A is true, let B be true. So let's fill in the first and second column. When A is true, let this be false. When A is false, let this be true. And finally, when both of them are false, false. So let's, with this is always there. Just choose any arrangement. True, true, false, false, true, false, false, true. So we said not A. Not A. So if it's true, it will be false. Not A is false. Opposite of true. Are you seeing? So for A, not A is now false because it's true. If it's A, this is what? Not A. This is false, so this should be true. Why this is not A, this should be true. It is not. So coming to B, the same thing, the opposite. So if this is true, this one will be false. False, true, true, false, false, true. So we are done with negating A and B. So they say A implies B. Remember, for A implies B to be false, the first one must be true, while the second one must be false. So that's it. Say it. The first must be true, while the second must be false. So with that, we can finish. Let's just look. Let's check where the first one is true and the second one is false. So let's check. True, false, true, false. So this is the only time it is false. Is there any other true first one? So others will be true. So the same thing, let's look at negative B implies. So where the first one, that negative B, is true, while the second one is false, so it should be this. So this is false. You see, true, while this is false. So others are true. So, and it seems our proof is correct. Everything on the last column is the same thing as the second to the last column. So we've proved that using truth table.